Hello everyone, welcome back to my channel. This is the ninth lecture series of my data science course. In this video, we will explore clustering in data science. So, basically, what is clustering? Clustering is a technique that helps us group similar data points, making it easier to analyze patterns and relationships. So, let's dive into the key concepts and applications. So, firstly, we will understand that what is clustering. So, clustering is all about grouping data into meaningful clusters or groups based on similarities. For example, grouping customers by their buying habits, etc. So, let's understand types of clustering. It includes partitional, hierarchical, density based, model based. So, partitional means dividing data into mutually exclusive clusters based on similarity. It divides data into separate groups like k-means. Hierarchical. It building a hierarchy of clusters based on their relationships. Hierarchical means build a tree-like structure of clusters. Density based. Identifying clusters based on regions of high data density. So it means groups data based on dense regions like DBS, DB Next is model based, assuming a specific probability distribution for each cluster. It means assumes clusters follow specific distributions like Gaussian mixture models, etc. Next is common clustering algorithms. It includes k-means, hierarchical, agglomerative clustering, DB-scan, Gaussian mixture models. So first understand k-means, a simple and popular algorithm for partitioning data into k cluster. So k means basically means divides data into k clusters based on centroids. Next is iterative process like assign, update, centroids. के मीन्स के कुछ प्रोज होते हैं एंड कॉन्स होते हैं जैसे कि फास्ट एंड इजी टू इम्प्लीमेंट cons are sensitive to outliers and initial choices of centroids. Next is hierarchical agglomerative clustering. So, in this clustering algorithm, a bottom-up approach to clustering, starting with individual data points and merging them into clusters. In this algorithm, it builds a tree-like structure of clusters, like algorithm bottom-up and divisive top-down. It has also its pros and cons. Pros like doesn't require the number of clusters upfront. Cons like computationally expensive. Next is DB scan, a density based algorithm that identifies clusters as regions of high data density. It basically it groups points based on density. It can identify outliers, noise. It also has its pros and cons like handles spherical clusters well. Parameters like epsilon can be hard to tune. Next is Gaussian mixture models, a probabilistic model based approach that assumes data points are drawn from mixture of Gaussian distribution. It basically means mean shift clustering. Arbitrarily shifts data point towards the mode suitable for arbitrary cluster shapes. Next is key matrices for evaluating cluster. It means intra-cluster distance like compactness, inter-cluster distance like separation, common matrices like Silhouette score and Days Baldwin index. Measures how well a data point belongs to its assigned cluster, evaluates the ratio of within cluster distance to between cluster distances. Done index evaluates the ratio of minimum between cluster distance to maximum within cluster distance. Next is challenges in clustering. like noise, outliers, high dimensionality, cluster shape. So, first understand noise. Random or irrelevant data points can disrupt cluster formation. Outliers. Extreme data points can distort cluster boundaries and affect performance. High dimensionality. Data with many features can make it difficult to identify meaningful clusters. Cluster shape. Traditional algorithms often struggle with clusters of irregular shapes. Next is practical applications of clustering. First is customer segmentation, means group customers into distinct segments based on purchasing behavior. Second is anomaly detection, identify unusual or unexpected data points that may signal fraud or system failures. Third is image segmentation, partition images into meaningful regions such as objects or backgrounds. Fourth is document clustering, it organizes documents into groups based on their content similarity. Fifth is social network analysis. Identify communities and group of users within social networks. Next is real world use cases of clustering. First is e-commerce recommendations. It suggests products to customers based on their purchase history and preferences. Second is medical diagnosis. It clusters patients based on symptoms and medical history to improve diagnosis accuracy. Third is fraud detection. Identify fraudulent transactions by grouping anomalous patterns in financial data. Fourth is bioinformatics. It analyzes gene expression data to identify clusters of genes with similar functions. Last one is marketing comparison optimization. Target marketing campaigns to specify customer segments for higher effectiveness. Next is, one second. Yes, so next is steps in clustering process. It includes data preparation, algorithmic selection, cluster evaluation, and interpretation. Data preparation means clean, pre-process, and prepare the data for clustering. As we learned in our previous video, how we prepare the data. Next is algorithm selection. Choose an appropriate clustering algorithm based on the data characteristics and goals. Third is cluster evaluation. It evaluates the quality of the clusters using various matrices. Interpretation. It interprets the result and derive meaningful insights from the clusters. So, next is conclusion. Clustering is a powerful technique in data science providing valuable insights into data structure and relationships. By understanding its principles and applying appropriate algorithms, we can unlock the potential of clustering for various applications. So, this is clustering K means in data science. I hope you understand this and like this video. Thank you for watching.